In this video, we are going to learn about oxidation number of an atom. Now, what is the oxidation number of an atom? It is the number that indicates the number of electrons that it gains or loses when it forms a bond. Now, isn't this very similar to the charge of the ion? To some extent, it is. Remember, when we have an ion, we have, for instance, calcium, we have Ca2+. That indicates that, hey, calcium has lost 2 electrons to become stable. Or we can have an oxygen that has gained 2 electrons to become an oxide. So we have O2-. But in this case, notice for an ion, the plus and the minus follow the number, where in oxidation is the other way around, where if I were to describe the oxidation number of calcium, would be +2. And oxygen will be -2. And notice how the plus and minus in front of the number. So this is the format for oxidation number. Where this is for the charges of ions. Okay, so know the difference between the two formats. The beautiful part about oxidation number is that it has a specific set of rules that we can use to find the exact oxidation number of a substance. The first one we have is elemental form substance. Now think of the term elemental, basically one element. So when we have one element substance, it will have an oxidation number of 0. Some of the common examples could be calcium solid. Notice how calcium by itself. Or we could have lithium solid, or we can have hydrogen gas, oxygen gas. Notice each of those has an oxidation number of 0 because it is elemental form. And then we have another rules for ions. Remember, oxidation is very similar to ions, so we can think ions, the oxidation number of an ion, especially monatomic ions, is equal to the charge of an ion. So the oxidation number of ions is the charge of an ion. That's simple enough. What about polyatomic ions? It is the same thing, but now we just have to think it is a sum of all the atoms. So for polyatomic ions, now remember, polyatomic ions are like carbonate, CO3 2-. So for the polyatomic ion, the sum of all the oxidation number of all the atoms, in this case carbon and oxygen, is equal to the charge of the polyatomic ions. So we take the oxidation number of carbon and all the oxygen here, and we add them all up, it would have an oxidation number of -2. Okay, so keep that in mind. Then we have another rule called a neutral compound. What is a neutral compound? A compound that doesn't have a charge. For a neutral compound, the sum of all the oxidation number of all the atoms, or ions, that's a specific part, in a neutral atom is equal to 0. What does that mean? If we have, let's say we have calcium carbonate, CO3. Remember, CO3 is a carbonate with the oxidation number equal to the charges of the polyatomic ion, which is -2. If carbonate is -2, calcium must be what? It must be +2, because +2 and -2 cancel out equal to 0. And that's how we use our knowledge about polyatomic ions to give us clue about the oxidation number of different substances in a neutral compound. Now what about an alkali metals? Alkali metals are in group 1A, remember, except for hydrogen. And just like the ions, it lost 1 electron. In this case, an alkali metal has an oxidation number of +1, indicating it will lose 1 electron in a chemical bond. Then group 2A, which is the alkaline earth metal, has a +2, which indicates that it will lose 2 electrons when it makes a bond with other substance. Then we have the halogen, group 7A, which need 1 more electron, a form of 1-. In this case, the oxidation number is -1, which represents that it will gain 1 electron when it forms a bond. Then we have some tricky rules that we have to remember. First, we have hydrogen. Remember, hydrogen is in group 1a, but hydrogen is a nonmetal that can gain 1 electron or lose 1 electron to be stable. When it is bonded to a nonmetal, it is losing 1 electron because nonmetals are very electronegative. They're very electronegative, so it will gain the electron from hydrogen. Now, when a hydrogen bonds to a metal, it is more electronegative, so it's going to gain the electron from metal. That's the reason why hydrogen has an oxidation number of -1 when it's bonded to a metal. So keep that in mind. This is a very tricky one because hydrogen is a very common atom that is very common in most compounds. The same thing with oxygen. Now oxygen, when it is in a peroxide, only in a peroxide, it has a -1. Where in every other compound that you see, in most of the compound that you see that's not peroxide, it would have a -2. For example, if we look at calcium oxide, we know calcium is in, let's say we don't know anything about oxygen, but we know calcium is in group 2a, so which give us 2+. So the total must equal to 0. What does oxygen has to be? Of course, it's gonna be -2. So as you can see, this is like a puzzle. You use what you know to find what you don't know. So what does that mean? Let's do an example where we have lead carbonate. Notice we don't have any rules about lead, but we have carbonate, which is a polyatomic ions. So the charge of the polyatomic ions also equal to what? The oxidation number of the polyatomic ions. So therefore, this one has a 2- because carbonate is 2-, so therefore the oxidation number is -2. So lead must be +2 because that is the only way that it will equal to 0. You see how that works? We combine multiple rules to find what is not given to us based on what the other rules give to us.